In most IT environments, we not only have to worry about reliability within our own networks and access within our own networks, but we also have to support access to our resources from outside our networks. And in the old days, when we talked about that, it was mostly remote workers dialing into our networks. But what's becoming more and more common is integration with other organizations outside our own network. So we're seeing a lot more cooperative interconnections between different companies. I work in healthcare, and in healthcare, it's not uncommon with hospitals and clinics and things like that to have connections between other organizations, sometimes even hundreds of them. So I work with hospitals that have hundreds and hundreds of connections to other organizations that are dedicated connections between these different networks so they can fully integrate their infrastructures for various reasons. It could be things like billing, sharing records, sharing patient records. If you think about it, if you go to, let's say you get sick and you go to your local ER and they decide that they need to transfer you to a major medical center like Temple or something like that, or University of Pennsylvania, maybe you want those records to seamlessly transfer from one to the other. And what would make that possible? And one example would be for remote access would be things like APIs, things like supporting VPNs and so forth and so on. So in this unit, I want to talk about not only remote access in the traditional sense of remote workers accessing our network, but also how we create networks that are interconnected between different organizations that are also secure, that we have some assurance that that traffic isn't public. It's sort of a private network between our different organizations. And if you think about it, in the old days, if you had an office building and you opened up a new building across town and you wanted to have a private network between those two buildings, kind of the simple way to do that that's completely private would be to have your own infrastructure. For example, we could each have a microwave dish on our building and we could create a point-to-point connection between the buildings, and we instantly have our own network, which works great for buildings that are across town or have some line of sight where you don't have a lot of distance, or that we can trench our own cables from one building to another. That all works great. But what happens if these buildings are across the world from each other? If I really wanted to have my own private network, I could either trench 1,000 miles of cable, which of course is absurd. No one's ever going to do that. Or I can launch my own satellite and we could each connect to a satellite somewhere. Or I can securely connect my two facilities through the internet. So I could take the internet, which already exists, which already has connectivity between these two buildings, and simply leverage that connection to create a secure connection for my infrastructure. So installing internetwork connections requires leased lines, data channels, all the expensive stuff that I just talked about. But when we wanted to connect to an organization's network, a more flexible option could be provided, and one of those would be VPNs. So I'm going to talk a lot about VPNs in this unit. So remote access could be unsecured dial-up connection points represent a substantial exposure to attack. For example, an attacker can use a device called a war dialer to locate connection points. So they can just dial over and over again, trying to find, we talked a little bit about that in attacks. I talk about that, in more detail in IT Security 2. We talk about some of these different network attack methods, and one of them is just dialing up modems to try to get access to something. And a variation on that is trying to connect to IP addresses to try to attack a network. So trying to see what's available for connection via IP address, because again, most people don't use dial-up anymore. So some of the technologies that can help prevent those attacks are things like Radius and TACACS and CHAP, all these different protocols that I talked about before. CHAP is not used much anymore, but point-to-point PPP and things like that. But we have these authentication things in place in order to try to protect access to our networks, but that doesn't necessarily protect the information in those networks, and it doesn't necessarily protect while it's in transit between networks. So let's talk about that a little bit. Well, actually, I already talked about Kerberos, so I'm going to skip that slide. Sorry, I had it in here kind of redundantly. But so a virtual private network, or a VPN, is where we leverage the public switched network, or the internet, as a connection mechanism, as a sort of transport mechanism between disparate networks. So it can securely extend your internal network beyond your boundaries to the internet. So you can sort of create this virtual tunnel through the internet where your traffic is protected. So you have trusted VPN, secure VPNs, and then a hybrid, which is both trusted and secure. What do we mean by that? So a trusted virtual private network is where we know the endpoints of the virtual network. So I know the traffic, we know there's an established route between the two nodes, and we know that the connection, that information came from the other device. In other words, somebody can't send traffic into my network unless they're from that trusted connection. So that means that point A and point B can communicate, and if somebody tries to communicate, tries to get into that channel, they can't do it because it's trusted. Both sides of the connection are known. But what somebody could do is, let's say we have this established connection. While somebody may not be able to inject themselves into that communication stream, they may be able to listen. They may be able to see those packets. They can see the contents of those packets. So we could also have VPNs where we secure the data. So maybe we don't care so much about the trust on who's on each side, but we do care about making sure that that data is protected. It has confidentiality, which we talked about in the IT security triad. So that would be secure. In reality, most VPNs are both. It's both protecting the endpoints and protecting the data while it's in transit to make sure that we can only establish a connection between two endpoints, and that while that data is in transit between the two, it's secure, so somebody can't actually look at that traffic. They can't see what the payload is. And that's what most VPNs are. So they accomplish this by using encapsulation of incoming and outgoing data. So they encapsulate to create that tunnel or between those two endpoints, and using encryption to make sure that the data within those packets can't be accessed. And of course, we use authentication as well. So most VPNs employ some sort of authentication to authenticate the endpoints to each other. The nice thing about VPNs, and one thing I want to make totally clear here about VPNs, is in many cases they are transparent to users. In most cases, they're transparent. So in other words, if I'm in Office A and I'm trying to access a resource that's in Office B, I don't have to know that that resource is on the other side of a VPN. If they're set up correctly and configured correctly, that user doesn't need to know that it's in a completely different office and it's across the wire somewhere across the wide area network. They're not even aware of all that infrastructure because it's all automatic. What a user would be aware of is if they're accessing the network from home. So let's say I'm at home and I want to access Drexel's network. I can use Drexel's virtual private network or VPN client. They use Cisco, I think, at Drexel. I haven't used it in a long time. But you can use their Cisco VPN client to create a connection from your computer to the Drexel network. And then you can access all the resources on Drexel as if you're sitting there on campus. And it's all completely transparent as long as that connection is established using your VPN software. So transport mode is when the data within the IP packet is encrypted, but the header information is not. It allows the user to establish a secure link directly with the remote host, encrypting only the data contents of a packet. So you'll see these in end-to-end transport of encrypted data, or remote access worker connects to an office network, for example. Tunnel mode is where we establish two perimeter tunnel servers to encrypt all traffic that will traverse the unsecured network. So that's more like what I was describing. We have two different offices, Office A and Office B, and they can send and receive data between each other, and no one even has to know that this tunnel is in place. So those are the basic concepts of VPNs. And again, I'll have the PowerPoint on Blackboard as well, so you can go through the PowerPoint. But your book does talk briefly about VPNs, and I wanted to talk a little about access control or remote access.